So welcome to Observe, Wonder, and Think, a green chemistry webinar series. We are so thrilled that you are joining us tonight. My name is Erin Mayer. I am a lead teacher with Beyond Benign, and I am joined this evening by an amazing team of lead teachers and others from the Beyond Benign organization who will be assisting in various capacities behind the scenes to help things run as smoothly as possible. We are really excited to once again feature our newly released book, Green Chemistry and Sustainable Science, A Green Approach to Sustainable STEM in K-12, in tonight's conversation. To get our evening started, we would love to learn a little bit about you. Please introduce yourself in the chat by sharing your name, location, and the grade level you represent. Please make sure that the name we see on your screen is the name that you would like to have printed on your certificate of attendance for this evening. This is how Beyond Benign gets the names to create those certificates and send them to you. Additionally, if you're comfortable doing so, we welcome and encourage you to share your video feed as it fosters a more intimate and engaging experience for everyone. We do understand, of course, that there are occasions when that's not possible, and we are certainly understanding of that. If you haven't done so already, we'd love to have you join us on social media by following us at Beyond Benign on these various social media channels. We are always excited to see posts sharing not only our content being used, but also innovative ideas that are created by our followers, as well as inspiring stories within the green chemistry community of educators implementing green chemistry practices within their classroom settings. I would also like to remind everyone that by registering for our webinar series, you've agreed to our code of conduct. We are essentially asking for all participants to be kind, accepting, and open to varying viewpoints and opinions. The series is being recorded, and while it is expected that the video feed will focus on the presenters, your voice and video feed could appear at some point. So by attending this discussion, you are giving your consent to allow us to post video and/or sound of you. As we launch into tonight's webinar, we also wish to acknowledge this unceded land on which Beyond Benign operates. For years, it has been the traditional land of the Pawtucket and the Massachusetts nations. We acknowledge the painful history of genocide, colonialism, and forced removal from this territory. We also acknowledge that further education is needed on our part to learn the full history of the land we occupy and all the indigenous peoples it belongs to. We would also like to give thanks to our sponsors who make this series possible. Beyond Benign is an organization working to foster a green chemistry community that empowers educators to transform chemistry education for a sustainable future. It's our vision to ensure the chemical building blocks of products used every day are healthy and safe for both humans and the environment. And we believe strongly that education is the most powerful and critical component to achieving this mission. This is why we're committed to pioneering a paradigm shift across the continuum of science education. The reality is that there is a demand for green chemistry skills, and we don't currently have the workforce equipped to solve sustainability problems using chemistry. We're excited to feature presenters throughout this series who are working to change this. Last month, in October, the Green Chemistry Teaching and Learning Community launched. This joint initiative between Beyond Benign and the ACS Green Chemistry Institute, with support from the sponsors you see on the screen, is a space for all of us to share, connect, learn, and grow. The GCTLC hosts a central online searchable library of green chemistry education resources, including but certainly not limited to lab experiments, lecture materials, and in-class activities. This hub also allows users to create profiles, connect and network together, share ideas and resources, collaborate, and give and receive feedback, as well as mentorship. As I mentioned before, we are so excited to feature 2 more activities in our newly released book in tonight's conversation. Green Chemistry and Sustainable Science, A Green Approach to Sustainable STEM in K-12 is available on the GCTLC. This guidebook was created by members of the New York Chemistry PLT and Beyond Benign lead teachers. The goal of the book is to support new and veteran teachers to use green chemistry principles as they engage all students in learning experiences through sustainable and safe means. By sharing New York standards-aligned activities, lessons, and a larger unit, we have provided practical examples of how to integrate green chemistry into instruction and promote active student learning of chemistry concepts. We have also included examples from elementary, middle, and high school to both show a progression of student experiences and demonstrate the practical implementation of green chemistry principles at any grade level. While we call this book the New York edition, aligning these activities to the New York State standards, these lessons can be utilized across the country as they can be aligned to NGSS and other state standards. Tonight, we will be highlighting activities from 2 chapters in the book. Beyond Benign Certified Lead Teacher Stefanie Loomis will get us started tonight by sharing the flame test activity from Chapter 3. This activity is geared towards the high school level. Veronica Morabito-Weeks, also a Beyond Benign Certified Lead Teacher, will follow. She will be sharing an activity focused on the animal adaptations and engineering design from Chapter 2 of the book, titled The ABCs of Biomimicry. This year, our Observe, Wonder, Think webinar series is highlighting the 12 principles of green chemistry with short, engaging classroom learning activities. Tonight's focus activities will be, or focus green chemistry principles, will be green chemistry principles number 1, number 4, number 10, and number 12. Before we dive into Stefanie's presentation, I'd like to take a moment to briefly review the principles she will be focusing on this evening. So principles 1 and 12 will be Stefanie's focus. Principle 1 states, it is better to prevent waste than to treat or clean up waste after it's been created. This principle is often referred to as the prevention principle. The other 11 principles are how-tos to achieve principle number 1. The second green chemistry principle Stefanie will be focusing on this evening is principle number 12, safer green chemistry for accident prevention. According to the American Chemistry Society, safety can be defined as the control of recognized hazards to achieve an acceptable level of risk. Green chemistry principle number 12 is known as the safety principle. This principle is the logical outcome of many of the other principles. In fact, it is practically impossible to achieve the goals of principle 12 without the implementation of at least one of the others. Eliminating exposure before it can occur should be the level of safety that we are all reaching for. So without further ado, I would like to introduce our first presenter, Beyond Benign Certified Lead Teacher Stefanie Loomis. Stefanie graduated with a bachelor's degree in chemistry with ACS certification from Siena College and started out her career as a pharmaceutical researcher. She realized very quickly that this was not the career path she wanted. Stefanie switched careers and started teaching. She got her master's in secondary education from the College of St. Rose and earned her certification in chemistry, physics, and general science from the state of New York. She has been teaching for 25 years and is the New York State Master Teacher Emeritus. Stefanie teaches at Catskill Senior High School in Catskill, New York. She is a lead teacher with Beyond Benign and recently was highlighted in the Beyond Benign newsletter. She is also a co-author of Green Chemistry and Sustainable Science, a green approach to sustainable STEM in K-12. As a final reminder, as we get started, our goal tonight is to engage in an interactive session. If you have any questions during Stefanie's presentation, please type them in the chat. It is my pleasure to turn over the dialogue to Stefanie Loomis.
Thank you. So welcome everyone. I'm going to be talking to you today about our flame test lab, and I'm just waiting to be able to. Erin, can we go to the next slide? Thanks. So this flame test lab, I have modified and edited over many years. And the question is, can flame tests be used to determine the identity of an unknown substance? So this is the question I start my lab out with every year. And every year, I look at ways to make this safer from the students and for the supplies that we're using and in the situations that we've been put in. So this lab has been modified through COVID. I've been able to use it. Last year, we had some construction woes in my building, and we weren't able to use some of the supplies that we had or be in the spaces that we are. And this year, I'm actually in a temporary room because of construction. So I can't actually be in my chemistry lab. But even with all of that going on, I'm able to still be able to run this flame test lab. And so I love the fact that it has such a safe way for us to engage in this lab. So you'll find the flame test lab in the Green Chemistry and Sustainable Science, a green approach to sustainable STEM. And these are all Word documents. So you can go in and edit and tweak it however you choose to do that. And I'm actually going to explain to you how I did that this year with the situation that I'm in. So we start off again with, can flame tests be used to determine the identity of an unknown substance? Have you ever observed fireworks in many different colors, and have you ever wondered why? The different colors of the flames or fireworks are produced when energy is emitted from the electrons. Electrons contain chemical energy in discrete amounts, and energy can be added or released only in discrete amounts or packets. When the electrons release energy, we see it as light, and the color of light depends on the amount of energy released from the electrons. Now, most of the time, I use the Bunsen burner to do this lab. I have the students burn. We have spray bottles of solutions, and the students can spray those spray bottles of solutions using the apparatus in the lab, and they're allowed to collect their data. Unfortunately, for the last few years, for one reason or another, I haven't been able to allow the students to use Bunsen burners. And that happened again this year. And so I had to modify how the students were doing the lab. So this link here is a Java lab. And I'm going to show you how I use this. So this little lab here allows the students to go in and click on the different salts, and they can actually see what colors they are. And so we go through each one. We go through sodium and then lithium. You can see potassium there. And you can see all the different substances, and they all produce different colors. And so we ask the students what colors they're observing from those salts. And so part of the lab is making connections to how those salts can be used. And so with that availability, it allowed me to have the students fill out and collect data. Oops. Hold on one second. I think I went too far. And so once they've collected their data, we then allow them to use what we call color flame candles. And you can buy these on Amazon or some other stores. And each of the candles will burn a different color. And so we have the students figure out which metals they think are present in those salts. And so what I did this year is I had the students watch the other video first. And then I had the students light their candles. So you can see these candles are actually lit in a flower bucket. So it was safe for the candles, and it gave us a place to burn them and observe them. So we made it really dark, and they could light each of those candles. So here's an orange candle. And then the purple candle. And our red candle. And we talked about, not only did we talk about the colors that we saw, but we were able to talk about the intensity of the colors that we saw and how different flames look different to them and what colors did they see. So this was the green and the purple together. And then at the end, we actually burned them all together so they could see all the different colors. And so how is this safer chemistry for accident prevention? So we didn't just give them the salts to burn over the Bunsen burners. We had these reusable candles that they were allowed to use. They blew them out, and then I could use them with multiple lab classes. And so it allowed us to collect that data from that. So the data table from the lab itself, oops. There it goes. So the data table from the original lab looks something like this. So they could figure out the candle color used, the metal, the color of the flame, and then we would give them unknown samples, and they would have to try to figure out what color they see and then know the identity of the unknown. So I did this a little differently this year, just because of, again, the situation I was in. So I had the students watch and use that Java lab to collect the metal and the color of the flame. And then we used the candles as all of our unknowns. And so the students went and lit the candles, And when they lit all those candles, they were able to say, okay, if this one is blue, then it must be this metal. And if this one was green, then it must be this metal. And they were able to put all of the metals with the colors, and they had discussions with each other about them. And so it allowed us to look at all the different colors and say, can this be used? And if it can be used, how can it be used? And so again, even with this table, I had to modify because of the situation I was in. Then from there, we have the students analyze the data. And so we asked them a bunch of different questions as they analyze the data. So they look at the energy. And so for the first question, you can see it says the energy of visible light increases as follows, and then list the ions used in the flame test in increasing order of energy. We had a really good conversation about the colors in the rainbow and why are they in the order that they are in. So it leads to a lot of discussion. And then you can see question 2 is what color would you expect sodium nitrate to burn when introduced to a flame? And so we talked about how we saw sodium in multiple ways. Now we're seeing sodium again. What can we do with that? We then talk about, why were some lights more intensive than others? Now I teach in a rural district. So my students are not used to seeing city lights and things like that. And so we talked about driving in the country and we're driving down the road. And if there was a really bright light, what would happen when you're driving? And so this allowed the students to have a discussion more about their community and tie into how that affects them. We talked about how these tests can be used. And then we talked about how does this lab fit in with the idea of the 12 principles of green chemistry. And the students came up with, well, you can reuse the candles and there wasn't a lot of waste and, the matches only let off a little bit of heat instead of using a Bunsen burner. And so they came up with all of these different ways that this lab really helps with the 12 principles of green chemistry. And so we have a lot of conversations about that and how it works and how we put it together going forward. And so some of the things that they came up with for waste prevention was that the flame test lab can be done with reusable candles and that these candles could be used for multiple groups. Erin, can you add the next pieces on? For some reason it's not coming up. Yeah, thank you. So it allowed the students to see, okay, so they're done with it. Can another group use the candles? And they were allowed to see that it was very quick. And then they had a discussion because 2 of the candles look very similar. And they're like, can we relight them? And so we got into a lot of conversations of how it's reusable. And so it wasn't like it was one and done. And a lot of people got to use those. We also talked about how we had to watch part of it in a video before we were able to burn the candles. And then investigation can be completed with a video. And there's a lot of YouTube videos out there that you can use for this. So if you can't have access to the material, or if you have a student at home. So during COVID, I actually had a video that I would send out to my students and we still did the lab, but it was video form. And so you can still get all of the ideas of this lab and not have to worry about what supplies maybe you're sending home, or if a student's absent, what can you do with it? So safer chemistry for accident prevention. So green chemistry can be used in the class without directly saying it to the students. So this is big for me. I don't always come out and say to the kids, hey, this follows the 12 principles of green chemistry. But I made everything in our room as safe and as comfortable as I can for them. So they want to do it. They want to mix things together. They want to touch things. And so they feel safe. And so the safer I can make them, the more chemistry we can get out of that. We have all different types of labs that we do with the students. And so I've spent so many years updating and rewriting my labs. And again, green chemistry doesn't have to be broadcasted to be green chemistry. So you can do this without making it or having to talk about it for not maybe quite understanding all of it. Now, avoiding solid salts that were typically used for the flame test lab and using salt solutions with salts that were safer based on their SDSs increased the safety of the lab. So I used to do the whole original lab where you would take the solid salts and you would dip it in, a piece of wood and you would burn it over the thing and the kids would see the flames. And we had so much salt that was out there of different metals and things like that. And then we realized you can make salt solutions and you can just spray them into the apparatus and get the same effect. And then I learned about these candles, which also adds on to those pieces. So I have modified this lab probably over the last 5 to 10 years. One of the big things I've learned about green chemistry is it's not a switch. It's not on green chemistry, off green chemistry. It's constantly reevaluating what you're doing and how you're doing it to make it safer for not only your students, for yourself, for your classroom, and for anything that's involved in what is going on. And so I find it really super important to remember that it's baby steps along the way and that everybody can do it. So consider one of your upcoming investigations or learning activities. How might you and your students integrate green chemistry principles into that lesson or activity? So if you have any ideas, feel free to put it in the chat, or you can let us know if you have any ideas of how that would work. Okay, Erin, I guess I don't know if anybody has any questions, but thank you.
Thank you so much, Stephanie. I love that you highlighted that it's baby steps with green chemistry, and it's just constantly reevaluating and rethinking. And how do you make small changes in something that you're already doing that's gonna matter, right? It's gonna be better for you or the kids or the environment. I mean, it's really just it's a mind shift, you know. It's just a mind shift. It's not reinventing things. So I love that you've highlighted that. All right. So again, chapter 2 of the book, you'll find all those resources, and it is it's an open source. And so as Stephanie said, and I think I saw in the chat as well, it is available for you to take and use however you choose. So modify, etc. Oh, and I love that. Yes. So this idea of going micro scale on labs. So again, just go scale it down, you know, and the kids will still get what they need to get out of it, but it's a smaller scale, less waste, less materials used in the first place. Let's see, and I'm looking at the chat. So there's a question. In doing these activities with your students, what would you say is the biggest challenge you have faced?
Now that my stuff is mostly green, I have to say I've eliminated a lot of challenges. Before it was setting up the chemicals, making sure I had the right amount of solutions, you know, were the students following the safety protocols? Were they doing what they were supposed to? And I feel like the more and more green and chemistry I use, the more household chemicals I use, it's more a simple of, did I go to the grocery store and pick up what I needed to now? I feel so much safer in my classroom, and I feel the kids do as well. And the fact that it's things they know about and they understand makes it such a huge difference.
Awesome. All right. Well, thank you so much, Stephanie. So we're gonna switch gears, and we are going to move from a high school setting to an elementary school setting with Beyond Benign lead teacher Veronica Morabito-Weeks. Before we dive into Veronica's presentation, I'd like to take a moment to briefly review the principles she will be focusing on. So we'll be looking at principles 4 and principles 10. So principle 4 is the focus is focusing on the design of safer chemicals. So the design of safer chemicals focuses on both minimizing toxicity while also maintaining function and efficacy. The American Chemistry Society states that achieving this goal requires an understanding of not only chemistry, but also of the principles of toxicology and environmental science. Green chemistry principle number 10 highlights the need to design for degradation. Green chemistry focuses on optimizing function while minimizing both hazard and risk. While principles 3, 4, 5, and 12 focus on the reduction of hazards, green chemistry principle 10 focuses on the design of products that degrade after use in order to reduce risk or harm. The level of risk is related to both hazard and exposure, the contact between a chemical and a living thing. Designing for degradation can eliminate significant exposure, which thereby minimizes risk. Once again, it is my pleasure to introduce Veronica Morabito-Weeks. Veronica graduated with a BA from the University of Arizona and a master's in elementary education from Dowling College. She's been teaching fifth grade for 28 years and is a New York State Master Teacher Emeritus. Veronica was presented with the Presidential Innovation Award for Environmental Educators in 2020, the Anton Banco Award for Excellence in Teaching Science in 2020, and the Stefanie Elementary Level Science Teacher of the Year Award in 2022. She's a lead teacher with Beyond Benign and a contributor to the Green Chemistry and Sustainable Science, a Green Approach to Sustainable STEM in K-12 book. So now, my pleasure to pass things over to Veronica.
Welcome, everyone. It's my pleasure to be here. My lesson is from chapter 2 of the book. It's an elementary level lesson called Impacts, Animal Adaptations, and Engineering Design. I'm very happy to be presenting this lesson tonight because I truly believe that it is important to expose elementary age students to the principles of green chemistry. However, the lesson that I'm presenting can certainly be modified for any grade level. So our goal tonight, the learning goal for this lesson is to introduce biomimicry and connect animal adaptations to examples of technologies inspired by animal forms. Also, to think about the ways that nature can help us perform in more energy efficient ways without making harmful waste or damaging the environment. Next. These are just some of the lesson resources, along with some additional resources about biomimicry that you may find interesting. You'll have access to those. So the phenomena that I like to use for this lesson is shown in the pictures on the slide. I asked the students what they noticed about the objects in the two pictures. They talk with a partner to share their thoughts, observations, and ideas. If you would like to add any observations that you happen to notice in the chat, feel free. So you may already know that the picture on the left is that of the Japanese Shinkansen bullet train, and the bird on the right is the kingfisher. Students may notice the similar shape of the kingfisher's beak with that of the front of the train. And a little background for you, the high speeds of this train caused a sonic boom when exiting tunnels. The engineers looked for ways to make the train more efficient and quieter. The general manager just happened to be a bird watcher, so he came up with these incredible designs inspired by birds. When the train's nose mirrored the kingfisher's uniquely shaped beak, the design helped the train reduce its noise level. The engineers also looked at feathers of owls and the belly of penguins to make the train more efficient and 10% faster. The next part is just to write the word biomimicry on the board, and we discuss and decode the word. It just helps the elementary students to understand it a little better. Next. The next part of the lesson is to give the students a KWL chart. They can fill in anything that they think they know about biomimicry, and then what they want to know about biomimicry. Now, we'll revisit this at the close of the lesson to fill in what they have learned, and it certainly can be used as a way to assess their learning, almost like an exit ticket. Next.
Yo, I poured me the biggest glass of wine. I filled that shit up to the top.
Then I hear some. Then I instruct the students to pay close attention to this MP3 video. Yes, it's right down here. It's a video clip about wasps. I don't think it's working, so I'll just tell you that it's a video clip about wasps. They share what they notice with a partner. They watch it a second time after being instructed to listen for the feature that the wasp has that inspired a better cardboard box. We discussed this as a whole class. And then I want to make sure that they understood that it was the petiole, the slender stalk between the abdomen and the thorax of the wasp, that inspired the scientist. And that's what they see on that video clip, is the scientist talking about it. And he felt and noticed that the petiole was so well built and well reinforced that if you could mimic the way the molecules are organized in wasp waste, you could have something that wouldn't bend easily, hence better and stronger cardboard boxes. Next. Then students open up page 3 of an issue of Conservationist for Kids. This is a wonderful magazine if you get a chance to look at it. And this page introduces green chemistry and sustainability. If time allows, I do like them to read the full issue because it offers many examples of biomimicry, and it's really worth allowing them time to explore the entire issue. There's 2 other examples from this Conservationist for Kids on the next slides. Next. Peacock feathers. So peacock feathers derive their colors from microscopic structures on their feathers. When the light shines on, it bounces off the structures to show a particular color, like the colors in a soap bubble. So scientists actually have used this as coatings for cars based on very small structures of the feathers. Next. Another adaptation is from hummingbirds. So hummingbirds have a unique ability to sustain hovering by flapping their wings forwards and backwards. A new wind turbine has been engineered to flap rather than spin, which increases its energy efficiency as it is able to generate energy on both the upstroke and the downstroke. Next. Let's see if this plays, but the students would get to watch this quick video. Thank you. I would love one of those in my backyard, actually. The wind turbine video introduces students to the innovative design developed by Tire Wind. And their wind turbine, as you saw, was inspired by hummingbirds, allowing them to develop a turbine that moves in a figure-8 configuration. It's smaller than conventional wind turbines. It uses less power and less space. Next. There should be the little, yes, thank you. So here, once again, we look at principle 4 and 10 using examples found in the issue of Conservationist for Kids. So 4, designing safer chemicals by using nature, animals, plants, and insects as inspiration for design. The chemicals and products are more harmonious with nature and therefore have less adverse effects. So for example, from the issue of Conservationist, if you can click the next. One of the examples is using sharks as inspiration to create products that keep bacteria from growing on different surfaces, and that decreases the need for harmful chemicals. 10, design for degradation. So again, we're using nature as inspiration for design. Chemicals and products will biodegrade, so they will not accumulate in the environment. Next box. So another example from the Conservationist for Kids was using mycelium mushroom roots to make plastic, and it requires less water, land resources, and is fully biodegradable. Next. So my final thoughts, I teach 5th grade, and I find that my students absolutely love biomimicry. They can just go wild with it. So we use this flow device. You'll see it in the bottom right corner, and it monitors the air quality in our classroom and playground. And the meter would show these extremely dangerous levels of particulate matter and toxins after the custodians would clean their desks. Kids noticed they had a lot of breathing problems and asthma attacks. So they wanted alternatives to the harsh chemicals. They looked at green cleaning products, and they also looked at biomimicry for solutions. They researched sharklet more in depth, and they thought that using this shark-inspired product on their desks and devices would inhibit bacteria and viruses without harmful chemicals. So you can see them fully embrace this whole concept of green chemistry. So as you can see, you can easily make a lesson meaningful for your students. Okay, so if you want to consider any investigations, you can certainly feel free to contact me with any ideas or questions that you have. Okay, thank you.
Thank you.
And again, if anybody has any questions, please feel free for Veronica to share them in the chat right now, and we'll try to get them answered. That was awesome. And I've done the sharklet, worked with sharklet and mycelium too, and it's just, you know, at the middle school level, and it's just, they're amazing. They're both really amazing to work with, and the kids really enjoy it. And again, it's just that using inspiration from what's already around us.
Right, and they just really jump in and get these great ideas. They saw that even being outside, our school happens to be right next to a huge highway and an industrial park, and they realized the playground was just so toxic. Our meter would show purple, which is extremely hazardous. And along the highway, they have these noise barriers. So the students said, you know what? What if we took those noise barriers and we use some kind of cork or some kind of material that would soak up these toxins? So not only are we limiting noise, but now we're saving our breathing. And it was just amazing to see them go wild and come up with all these inspiring ideas.
Well, and you're teaching them to be problem solvers. So,
yeah, that's it.
You know,
yeah, I keep telling them, you can change the world.
Yeah.
You know, you have to get excited like they do, and they come up with some fantastic ideas.
Yeah, I'm curious, where do you buy the mushroom mycelium from? Because I've been looking for it and I can't find it.
When I used it, believe it or not, I bought it off of Amazon.
Oh, Amazon sells it.
That's where there's a couple of lessons that I've done. One was with Chinese yams. I bought that off of Amazon too. So sometimes you get lucky with that.
Okay, cool.
I can definitely let you know if I
China,
find,
so that would solve the problem.
and I think eBay once I found it too. So I'll look. I'll let you know if I find it. If you want to.
Yeah, I'd love to do this with my students.
Okay, great.
Thank you.
And
So
there
you can
are
make cell phone covers with the mycelium, which is really, they flip over that.
so in that the cell phone cover with the mycelium is a Beyond Benign engineering activity, which those are on the Beyond Benign site under K-12 resources. But I also think they've been added to the GCTLC, and I believe they have direct links to the mycelium, like how other places you can order it right there in the actual lesson plan.
Perfect. Thank you.
Yeah. All right. Awesome. So thank you so much, Veronica, for sharing those awesome, amazing activities and resources and experiences, and just for getting little kids excited, right? And empowering them to be the future problem solvers.
That's half the battle.
Chloe, you did hear mycelium phone case correctly. Like, that is what the Beyond Benign activity is for kids to engineer a phone case out of the mycelium. Yes. All right. So before we sign off for this evening, I would like to invite you to join us for the next Observe, Wonder, Think. We will be taking a break in the month of December before we reconvene on Thursday, January 18th at 7 o'clock Eastern Time. High school teacher Jessica Lorenz will be sharing how the Bellingham High School Chemistry team has been researching new green chemistry lab experiments to replace high-risk experiments. Please do not forget to join the dialogue on our social media accounts for Beyond Benign. Also, on the third Wednesday of each month, Beyond Benign offers another interactive webinar featuring community leaders and active practitioners in the field, with both small group discussions, resource sharing, and networking opportunities with industry leaders and the higher ed community. Participants bring their own resources and share them out to the community. While their meeting time from 12 to 2 p.m. may not be convenient for K-12 teachers for obvious reasons, if you register for the webinar, you will have access to all the recordings, just like you do for Observe, Wonder, Think. And it might be something that you would like to share with educators and administrators who do not have a classroom schedule to increase their understanding of green chemistry. Also, we would like to highlight the ACS campaign for a sustainable future. And the Green Chemistry Institute, together with ACS Division of Education and Beyond Benign Green Chemistry Education, is having their second annual ACS Sustainability Summit with a focus of reimagining chemistry education. So that is coming up next month as well. And it's virtual and it's free. And then finally, if you haven't done so already, please scan the QR code that you see on the screen in front of you for more information about the green chemistry teaching and learning community. And this will also allow you to remain current with the latest news and events about green chemistry and the Beyond Benign organization and events. And one last time, thank you so much to our amazing presenters this evening, Veronica and Stefanie. We appreciate you sharing your time and your talents and your positive energy and all of your wealth of knowledge as you've been integrating green chemistry with your students at the elementary and high school levels for multiple years. And finally, we would like to thank the participants for tuning in tonight and sharing your time and being present in our webinar. We look forward to seeing you again in the new year. Good night and take care.